The topic here is volumes of solids of revolution, and we're going to use the washer method. So let's do example 5. The region bounded by the parabolas y equal x squared and the line y equal 2x in the first quadrant is revolved about the y-axis to generate a solid. So first of all, since it's revolved about y-axis, then automatically we know that the volume, we're going to use the formula of volume is equal integral from a to b of a of y dy. Next, we need to draw the region. To draw the region, we have to find the intersection of both curves. To find the intersection, we always set the y equal to each other. In other words, x squared, find the point of intersection. In other words, x squared, we're going to set it equal to 2x, which means subtract the 2x, x squared minus 2x is 0. Factor the x. If you factor the x, you get x minus 2. So this means x is equal 0 or x is equal 2. When x is equal 0, the y value, just plug it in into x squared or 2x, doesn't matter. If you plug it in, you get a 0. Then when x is equal to, plug it in into x squared or into 2x, doesn't matter. You'll get 4, y equal 4. So the point of intersection, the first one is 0, 0. Second point of intersection is 2, 4. So it's right here, 0, 0. And then 2, 1, 2, 3, 4, 2, 4. Now let's draw. So y equal x squared, it's a parabola, but we're not going to draw all of it. All we need is the part in the first quadrant. So it's going to look more like this, right? And then the line y equal 2x in the first quadrant will be just this piece. So in other words, this is the region that's going to be revolved about the y-axis. So in this case, we take this segment. This is the segment. If we take that segment and we revolve it about the y-axis, by the way, this is supposed to be y-axis. About the y-axis, of course, we're going to get a washer that's going to look like this. So the washer is going to have the R inner, the radius, the inner radius, and then the outer radius. When we revolve a region around y-axis, we want these curves, we want to write them as x as a function of y. So this curve right here, it was y equal x squared. If we solve for x, we get minus or plus square root of y, but we only need square root of y, just the one on the right side. So that's x equal square root of y, right? And this line let's do it here. Y is equal to x. If we solve for x, we get x equal y over 2. So let's do both. So this is x equal y over 2. X equals square root of y, right? And then x equal y over 2. Next, we need to find the inner radius and the outer radius. The inner radius goes from, let's do it this way. It goes from here, to this line. So R inner, I don't know where to write it down. So the R inner will be equal y over 2. right? So in other words, we're taking, this is y, right? So if this is a y, then from here to here will be y over 2, right? Because it goes from the y-axis to the curve x equal y over 2. So it's an x value, so it's equal y over 2. So the r inner, let me write it here, the r inner is going to be equal y over 2. What about the r outer? The outer radius goes from, let's do it here because I can see it here, from here to here, right? So the r outer is gonna go, it's gonna be square root of y, right? Because this is x, right? It's going from here to here. So now the rest is pretty easy. So the volume, like always, it's gonna go from y equal 2, from y equals 0 to 4, right here, y equals 0 to y equal 4, right? From y equals 0 to y equal 4, and then it's pi, and then r outer, which is r outer squared, which is square root of y squared, minus pi times the r inner square, which is y over 2 squared, and dy. So remember, v is always, let me write it here, is always going to be equal ab. When we have a washer, r pi r outer squared minus pi r inner squared dy. So to finish this, v is equal integral from 0 to 4 pi square root of y squared is y minus pi, and that would be y squared over 4 dy. We can take the pi outside, which is equal to pi, and then integral will be equal and it's y squared over 2 minus y cubed over 12, and it's between 0 and 4. Just plug in the 4, so that would be 4 squared over 2 minus 4 cubed over 2 minus, and then when you plug a 0, of course you're gonna get a 0. And if you do all that, you're supposed to get 8 over 3 pi. That would be the answer. So let's just try to graph. Let's try to graph the solid. If you try to graph the solid, this is how it's gonna look like. Minus 2. I'm gonna go here. Reflection. So all you need to do is graph this way and do this segment line. And then revolved. So this is how it's gonna look like. And that's it for this example.